one or something very innovative. Ultrasonic sensor, in the sense that it is a class of sensor where non-invasive measurement is sensing is done. So from that, and comparatively, you can say that it is non-invasive as well as it is comparatively new type of sensing. So in this case, the major attraction is that you're not supposed to insert anything inside the channel for the measurement of flow. So here you can see that it is having two sensors. Obviously, we have when you go to the market and you want to purchase an ultrasonic sensor, then you will get a sensor and detector pair. So here in this case, anyway, you can have a separate also. You can. So in this case, these two sensing units, you can say, together, a transmitter and receiver is used, one at this point and another. And if your liquid is flowing in this direction, then basically the main concept in this sensing is that when your ultrasonic signal is released from transmitted from here and it is received here. So when you will compare the received signal with the transmitted signal, there will be a phase difference, and this phase difference will depend upon the fluid flow. So by measuring the phase difference, we can measure because phase difference will be the function of the fluid flow, fluid flow rate in the channel. So by measuring this, the phase difference, we can measure the fluid flow. The setup is very simple. Here we are having one oscillator and one detector, and then first of all, your oscillator is put here and your detector here, and then one reading is taken. Then their positions are reversed. Then another reading is taken. So this is how experiment is done. That's why this reverse switch is here. And this is the distance between means when this is transmitter, this is detector. When this is transmitter, then this is detector. So the distance between transmitter and detector is this. All these things I had written here. Just a minute. हेलो, वालेकुम सलाम जी, बोलिए. हाँ बोलिए जस. तो आप हमें एक मेल भेज दीजिए भाई, हम आपको जो है लिटरेचर भेज देंगे, फिर आप हमसे एक बार मिल लीजिएगा, ठीक है. हम लिटरेचर भेज रहे हैं, आप उसको पढ़िए, मेरे कांटेक्ट में रहिए, क्योंकि अभी आपको एक एब्स्ट्रैक्ट जमा करना पड़ेगा, ठीक है. अभी मैं क्लास ले रहा हूँ, तो आप मुझे एक मेल कर दीजिए और सेकेंड हाफ में मुझसे कंसल्ट कर लीजिए, हम आपको समझा देंगे क्या करना है, ठीक है. ठीक ठीक. So whatever I explained is written here. Now here in this case, if you look, if this is the fluid flow direction, then when this is your oscillator and this is detector position, then your signal is flowing in the direction of flow. And when this is oscillator and this is detector, then signal, ultrasonic signal, will flow opposite to that of your fluid flow direction. Is it fine to all of you, whatever I'm trying to explain as far as this experimental setup is concerned? I feel that everybody is comfortable with it, because with reference to this setup, I'll have derivation. So if this is clear to all of you, this setup is clear to all of you? जी, इसमें कोई डाउट है तो पूछ लीजिए. हाँ भाई.
Yes.
It is fine to all of you? Now in this case, you see, transit time means the signal which will take, how much time will it take to reach from transmitter to receiver in direction of flow. When in direction of flow means when A is oscillator and B is detector. When A is oscillator, and B is detector, and this is the direction of fluid flow. So obviously, the transit time, the signal which takes the time to reach your detector will be this, because in this case your fluid flow, this is your fluid flow rate, speed, and this is your signal speed. So obviously both of them are in the same, flowing in the same direction, your signal as well as your fluid. So your fluid flow will uh, aid the signal flow direction. So this is the जी शायद भाई सलाम वालेकुम। या मैं क्लास ले रहा था मैं डिपार्टमेंट में हूँ। मुझे बताइए कोई वो हो तो। हाँ बताइए। हम्म। जी 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 जी। हम्म। वो मैं देखिए, मैंने तो काम उस पे किया नहीं है कंसोल पे, मैं स्टूडेंट्स ने काम किया है। तो जो भी है हम आपको एक बात करा देंगे स्टूडेंट से अपने, ठीक है। कॉस्ट तो कॉस्टली है सॉफ्टवेयर वो। अब वो एग्जैक्टली मैंने जो उसका वो खरीदा तो नहीं है, अ, क्योंकि पर बच्चे इधर उधर से ही मैनेज कर रहे हैं। अलीगढ़ में डिपार्टमेंट में है। हाँ वो भी उनके पास, हाँ वो एनसिस है, एनसिस मल्टीफिल एनसिस वो है, तो वो हम उनको एक्नॉलेज कर देते हैं। मैं उनसे पूछ के बता देता हूँ, अलीगढ़ वालों से पूछ के। ठीक ठीक ठीक। ठीक है ना। हाँ, I'm sorry. So this is obviously the distance upon speed will give you the time. Um, so this is the time lag because of which we will have the phase difference. Now, if the signal means your ultrasonic signal is frequency f, then phase shift, that whatever phase shift that will take place because of this delay, it will be obviously omega t1. So it will be this is the phase shift in the signal, whatever signal which is received at the detector when compared with the transmitted signal, then it will have a phase difference of this much. This we are able to find out. Now will have the opposite direction. Now setup has been reversed. That's why this reverse key is used. So now this is your transmitter and this is your detector. Now in this case obviously your signal is flowing opposite to that of fluid flow. So in this case your fluid flow will oppose the signal flow. So in this case, your time, transit time will be d upon c minus v. Obviously, both of them are in opposite to each other, so it is c minus v, and the resultant phase difference will be omega t2. So this is your phase difference. In the case when your signal is moving, signal is transmitted against, is flowing against the direction of fluid flow, then we are taking the sub means the difference of these two. This difference process, I think I may have talked about it earlier also. This difference process is very much favorable in instrumentation, because we are measuring one parameter, phi1 and phi2, and then we are taking difference of these two. This is if your instrument or your setup is having some offset error, that will be present obviously in this reading as well as in this reading. When we'll take the difference of these two readings, so all those error, offset error, constant error which is present in your readings will get cancelled. So many time this is a favorable operation that we prefer. So anyway, we'll take the difference of these two phase differences, and then finally we'll have this expression. And if you look upon this expression, this is the exact expression. So your difference of phase difference is proportional to the velocity of the fluid, and as the velocity of the fluid will vary, your difference of the phase difference will vary. Now we'll make certain approximation that your V, obviously fluid flow is speed of the fluid flow will be very less in comparison to the speed of the ultrasonic signal. So in denominator, obviously C will be C square, V square may be neglected in comparison to C square because of this fact. So this will simplify our expression to this, and obviously if you look upon because there is a major problem in means why we try to simplify it, although it is approximation, it is not. So if you look upon this expression, and if you look upon the relation between delta phi and V, so it is non-linear because your V it is not a straight line relationship, it is a non-linear because your V square is present in the denominator and your V is present here. But if you look upon the approximate expression, then it is a linear expression because all these parameters are constant, and this, so that's why it is kV, provided all these parameters should remain constant. So if it is constant, then it is a straight line. So we can say that as far as this Doppler flow meter setup is concerned, its resultant expression is basically non-linear, but this non-linearity is not very high because of this fact. Okay, and it can be approximated by linear expression. This is what is the, but there is a major problem, but I'll come to that major problem only if everybody is fine with the this derivation whatever I explained here. If anybody is having any problem with any of the steps of this derivation, you can ask please. जी बताइए, किसी को कोई प्रॉब्लम है?
No, sir.
There is one issue, the difference between two phases. This is all I had already spoke about. This is the very sensitive also, 1 millimeter per second can be measured. This is a very important issue which is present with this flow meter. Here in this case, actually, your final expression is you can see that dependent upon the velocity of ultrasonic signal. This velocity of ultrasonic signal is temperature dependent, is pressure dependent, so, and a fluid dependent also. So this medium dependence, that's what I want to say. So this speed, although we are considering it constant, but it is not constant because of its dependence upon. So suppose you have taken one value for this C for certain temperature and certain pressure, certain condition, but when you are performing the experiment, temperature has changed to some other value, pressure has changed to some other value, liquid is not that liquid for which you have taken C. So obviously your constant will change. This constant is not remain constant. Okay, are you fine, all of you? So this is a very important issue which is present. This is a disadvantage, this is a limitation of this method. So so that's why it is written uncertainty of value of C may be source of an error. This is a big, means there will be a characteristic drift. So this is a major issue we have in this type of sensor. And then another thing is that your flow channel wall should be such that, means your signal should travel always. You have to make sure that whatever signal which we are receiving at the detector end, that signal should come through the fluid only, should not come through the channel wall. So this is another, although this is a quite obvious requirement, you have to make sure, or if we are getting certain signals, then we should use signal conditioning circuit to cancel it. So this issue whatever I discussed if anybody is having any question regarding it. This is a very important point. So solution is that we should have means this is the issue that C means this issue because your expression is having this C term, and the solution is that if somehow we make a setup, experimental setup, which should have a expression, a calibration expression it is called, or a transfer function, or the response equation, it should not, it should be independent of C. If this is possible, only then you won't have the limitation, whatever we are having limitation in this case, in this setup. Is it fine?
Yes, sir. Sir, I'm asking question, sir.
जी बताइए बताइए बताइए, you are welcome.
सर सर जो V है अगर वो लाइट स्पीड का लाइट से कंपेरेबल स्पीड में हुआ है एक इमेजिनरी सिचुएशन में
This is not light, this is ultrasound. It is a high frequency audio signal.
सर व्हाट इज
It's,
द वैल्यू ऑफ C constant
what is the value of?
C then
You can Google it, speed, because your speed of ultrasound sonic signal, ultrasound is very common, but it depends upon the medium to which it is traveling. So you have to specify the medium also. It is
so
not like electromagnetic signal
so
which can travel through the vacuum. It cannot travel through the vacuum. It requires a medium. But if you'll change the medium, or you'll change the medium environmental condition, then its speed will change.
yes sir of course
Okay,
hmm.
so that is the issue here. So if your liquid is changing or your temperature is changing, so obviously we require the, for calibration we require the value of this K, and this K value depends upon, apart from other thing, it depends upon the speed of the ultrasonic signal. But we are assuming here it is as a constant, but it is really not a constant. So if for the specified condition for which you have taken a value of C to calculate the value of K, then and if your experimental condition changes from that value, then obviously this K value will be different, and obviously your speed will be different. So whatever speed you will calculate with the K value, which is no more valued because of the uncertainty in the value of C, it will fetch you the value of the fluid flow velocity will be erroneous. It will be different. Your speed is different, and your calculated value or your measured value will be different. You understanding what I'm saying?
yes
So this is the major issue that we have in Doppler flow meter. This issue is taken care of in this setup that is called transit time flow meter. Although I don't say it is another method, I would say that it is basically the modification of first method, whatever. And this method, the motivation is this issue, that issue I discuss here. Actually, today I'll close my lecture here only because I'm having some university engagement. So I have to go somewhere. So in this case, I'm just introducing it, and then I'll close today's lecture here. So in this case, basically we are having a setup, like instead of one pair of transmitter and receiver, we are having two pairs of transmitter, and they are basically installed across the channel. Like transmitter A is this, and receiver or detector A is this, and transmitter B is this, and receiver. And then obviously your fluid is flowing in this direction. And जी नूर रजा साहब, अस्सलाम वालेकुम। हेलो जी, वालेकुम सलाम। अल्लाह का नाम। नहीं, आप अगर नहीं जाना चाहते तो रुक जाइए, कोई बात नहीं। हाँ, क्योंकि आपकी क्वेरी में वो आ सकता है, क्योंकि हम आपने दिया नहीं है, तो उसमें यही समझाना पड़े इसमें आपको क्या नहीं समझ में आ रहा है। तो आई ट्राई टू हैंडल इट, कोई ऐसी बात नहीं है, क्योंकि उसका जवाब दिया नहीं गया है। अब खैर अब तो उनका कमीशन का ऑर्डर ही आएगा जो भी हो, तो आई ट्राई टू, कोई ऐसा इशू नहीं है उसमें, उसमें कोई ऐसा इशू नहीं। नहीं आप थोड़ा सा आराम करिए, आपके साथ प्रॉब्लम दूसरी भी है। ठीक है कोई बात नहीं, वो तो उस दिन भी मैंने आपको कह दिया था कि आपके लिए कोई नहीं, अच्छा रहता है, कोई चलता है साथ तो अच्छा रहता है। ठीक, ठीक, ओके, थैंक यू। So in this case, the setup is like this, and then concept remains same here also. There is a shifting, and then I'm not basically explaining it right now. So finally, you see the time or frequency shift is measured. It is also transit time difference only, and here you can see this is the final expression. And here you can see the beauty of this setup is that there is no C expression present here. Although in the previous initial expressions your C is present, but finally it is cancelled. And so this is the beauty of this setup. So I'll take up this in detail on the next and tomorrow, the first period. Okay. So I'm closing today's lecture here. And if you are having any difficulty in understanding anything that I discussed today, you can ask tomorrow also.